Sea level rise this century may disproportionately affect certain Asian megacities as well as western tropical Pacific islands and the western Indian Ocean, according to new research that looks at the effects of natural sea level fluctuations on the projected rise due to climate change. The study, co-authored by a scientist at the National Center for Atmospheric Research, or NCAR, mapped sea level hotspots around the globe. The research team identified several Asian megacities that may face especially significant risks by 2100 if society emits high levels of greenhouse gases: Chennai, Kolkata, Yangon, Bangkok, Ho Chi Minh City, and Manila. The study, published in Nature Climate Change, was supported by the U.S. National Science Foundation, NCAR's sponsor. Scientists have long known that sea levels will rise with increasing ocean temperatures, largely because water expands when it warms and melting ice sheets release more water into the oceans. Studies have also indicated that sea level rise will vary regionally because shifts in ocean currents will likely direct more water to certain coastlines, including the northeastern U.S. What's notable about the new study is the way it incorporates naturally occurring sea level fluctuations caused by such events as El Niño or changes in the water cycle, a process known as internal climate variability. By using both a computer model of global climate and a specialized statistical model, the scientists could determine the extent to which these natural fluctuations can amplify or reduce the impact of climate change on sea level rise along certain coastlines. The study showed that internal climate variability could increase sea level rise in some locations by 20% minus 30% more than what would result from climate change alone, exponentially increasing extreme flooding events. In Manila, for example, coastal flooding events are predicted to occur 18 times more often by 2100 than in 2006, based solely on climate change. But in a worst-case scenario, they could occur 96 times more often based on a combination of climate change and internal climate variability. Internal climate variability will also increase sea level rise along the west coasts of the U.S. and Australia. The study drew on a set of simulations conducted with the NCAR-based Community Earth System model that assumes society this century emits greenhouse gases at a high rate. The simulations were run at the NCAR Wyoming Supercomputing Center. The paper stressed that the estimates of sea level rise come with considerable uncertainties because of the complex and unpredictable interactions in Earth's climate system. But the authors said it's critical for society to be aware of the potential of extreme sea level rise to develop effective adaptation strategies. The internal climate variability can greatly reinforce or suppress the sea level rise caused by climate change, said NCAR scientist Aixu Hu, who co-authored the paper. In a worst-case scenario, the combined effect of climate change and internal climate variability could result in local sea levels rising by more than 50% of what is due to climate change alone, thus posing significant risks of more severe flooding to coastal megacities and threatening millions of people.